Hey everyone, welcome back to our Python programming series. Today we are diving into the world of Python libraries, specifically external libraries and custom libraries. In part 1, we talked about Python's built-in libraries, so in this part, we will explore other libraries that are created. Let's get started. Python's strength lies not only in its core language features but also in the vast ecosystem of thousands of external libraries hosted on the Python package index PyPI. PyPI, as an open source repository, houses libraries contributed by developers worldwide, covering diverse domains such as data analysis, artificial intelligence, web development, and network programming. These libraries enable developers to save time by integrating ready-to-use, optimized tools into their projects instead of writing code from scratch. Popular libraries like NumPy, Matplotlib, and Requests save time by providing ready-to-use tools for data analysis, visualization, and networking. For instance, NumPy offers high-performance multidimensional arrays and mathematical functions for scientific computing and data analysis, while Matplotlib provides a powerful tool for creating visualizations. In addition to leveraging external libraries, Python developers can create custom libraries to organize and reuse their own code across multiple projects. Custom libraries are ideal for consolidating commonly used functions or modules, enabling developers to streamline their workflows. For example, a developer might package frequently used data processing functions or algorithms into a library, which can then be imported into different projects to avoid code duplication. On the screen, you can see PyPI's official website. PyPI helps you to find, install, and publish Python packets with the Python package index. You can see the statistics here, and you can use a search bar to search for external libraries. You should always check the library's documentation on PyPI or its official website to understand how to use it and ensure it's actively maintained. Also, consider using virtual environments to manage your project's dependencies. So let's search for NumPy in example, and results are listed on screen. As you can see, there are many packets appropriate for installing. Let's click the most relevant one, NumPy, and you can see here a command that can be copied by clicking on this button. It's copy to clipboard button. After that, it automatically copies the installation command, and you can check project description, release history, download files, and so many from here. For NumPy, its website, documentation, mailing list, etc. are listed here. You can see basic instructions, but if you want to check for more detailed ones, you can click on documentation link presented here. And you can choose a version. Not all the libraries are complex like that, but for NumPy, it's in this way. Some libraries even require a few lines only, so they are easier to use. And you can see various guides appear here. Let's click on the Absolute Beginner's Guide, and here we go. There are codes for how to import it, how to create arrays, and what is array. It explains all of them. There are also specific things like adding, removing, and sorting elements, shape of arrays, etc. So, in order to install or remove external libraries, you have to use Python's standard package manager. Pip. Pip is an indispensable tool that simplifies the process of accessing and managing the vast array of libraries available on Python package index PyPI. By executing straightforward commands such as pip install to add libraries like NumPy, Matplotlib, or requests, pip uninstall to remove unwanted packages, or pip install upgrade to update libraries to their latest versions, developers can seamlessly integrate powerful tools into their projects, significantly enhancing productivity and reducing development time. Beyond basic installation, pip offers advanced features like version control, allowing developers to specify exact library versions for compatibility or to ensure reproducibility across different environments. It also supports the installation of custom or proprietary libraries, enabling developers to manage in-house packages with the same ease as open source ones. So let's type pip install NumPy. I already had it, so if you don't, it will download and install automatically. It uses the cached version. Okay, it raises some compatibility errors, but it's okay since I will just demonstrate examples about NumPy. You can uninstall it, uninstall using pip again. So pip uninstall NumPy and type Y. It says successfully uninstalled. If you want to install clear version using no cache, let's just do it. First clear the screen, then pip install numpy no cache with double hyphens, after that no hyphen cache. It first downloads, as you can see, collects and installs it again. Okay, we are done for now. Let's open our code editor. So now let's try the library we have installed recently. Let's type import numpy as np. If you remember, this is an alias, so you can access its tools with np prefix. Let's create an array. Array equals np dot array 1, 2, 3. Things we have seen in its documentation. Then print array dot shape, and let's run this code. Okay, it displays 3 comma, so it means it's a vector of 3 elements. You do something like this. Let's make it 2D, a matrix, 4, 5, and 6. So now it's 2 by 3. We are not going for a full tutorial on NumPy in this video, but we have seen the basics of installing and using an external library. There might be difference between the import names and install names of some Python libraries, and it's primarily due to naming conventions, historical reasons, package organization, or practical considerations. So you have to check documentation when installing a library. The install name refers to the package name registered on the Python package index PyPI, which is typically chosen to be unique, descriptive, or aligned with the project's branding. However, the import name used in Python code with the import statement may differ because it reflects the internal module name or a more concise alias designed for coding convenience. For example, the library installed via pip install pylo is imported as PIL because PIL is the name of the core module, reflecting its historical roots as a fork of the original Python imaging library. Sometimes the import name also corresponds to a specific module or subpackage within library. You might import only some of the tools from it. Now everyone, let's see how to create and manage your custom library. Custom libraries are libraries you can create to organize and reuse your own code. Let's say you have written a set of functions like in here for a calculator to use across multiple projects. Instead of copying and pasting them, you can package them into a custom library. So I named my Python file as mylib.py and I created a class of calculator for basic arithmetic operations. It initializes with a result of 0, includes functions like add, subtract, and get result. Outside, we have two functions to use directly from the library without using the class. They are named as square number and greet user respectively. They are in the same folder, so can use it directly by importing it at the top of our code. So let's return to main.py and start using it. Just type import mylib. Will recognize since it's in the same directory, importing custom lib. Now let's greet user. Type print my library dot greet user learn at Hive and run it. It displays hello learn at Hive. Welcome to my custom library. So we have called our first function. Now let's do something more advanced. Let's create class calc equals mylib.calculator calc.add 10 print calc.getResult. I'm using tab to autocomplete calc.subtract 5 and print calc.getResult again. Let's run and see. It reloaded our model. It prints hello, learn at high, welcome to my custom library. After that, it prints 10 and 5 respectively. So we are successful here and we have created a dynamic calculator class. Now let's use square number function which doesn't affect our calc object. Let's print my library dot square number 5, and if you run it you will see the 25 as the output. So it worked. You create a Python file, say my library.py, and define your functions, classes, etc. After that, to use this in another script, just import it and place it in the same directory. If you want to take it a step further, you can structure your custom library as a Python package. You can even distribute it on PyPI if you want to share it with others. We will see it in another video, but you just have to create a folder with an init file to make it a package and organize your models inside. External libraries let you tap into the power of the Python ecosystem, while custom libraries help you organize your own code like a pro. Try libraries like Pandas or create your own utility model for your next project. If you found this video helpful, give it a thumbs up, subscribe for more Python tutorials, and let me know in the comments what libraries you love using. So maybe in the future I can upload tutorials about them. See you in the next one.